Hi everyone, I'm Miss Eckert. I'm going to be talking you guys through lesson 3, so make sure that you see lesson 3 at the top of your paper. It should say graphing systems of equations and inequalities. So if you don't have that paper in front of you, make sure you go to the right video. This is lesson 3, okay? Okay, so lesson 3 is all about systems of inequalities and systems of equations. There's going to be a little bit of review at first, so it's reviewing stuff that you learned in lesson 1, which is graphing equations and inequalities. So I'm going to go over a few examples that relate to that lesson, but if you feel like you are still having difficulty with graphing inequalities or equations, please check back with lesson 1 and review what you did there. So when we are graphing linear functions or linear equations, there are a couple important things to remember. So we want to be able to identify our y-intercept, which is where the line crosses over the y-axis. Right? Another way of thinking of that is determining what the value of y is when x is 0. So I know that on my graph, my point, whatever my y-intercept is going to be on the y-axis here. The second thing that's important to remember is your slope. So that's how do you get from one point to the next. Remember rise over run. So that's how much are you increasing by going up or down, and then how much are you going left or right, your change in x. One thing that you will notice on your paper, right, if you have it in front of you or on the computer, I accidentally switched the two graphs. So I'm going to do the graph correctly here, but if you are looking at the example that already has the graph on there, just switch those two graphs when you're looking at them, because I accidentally put them in the wrong spot. Okay, so number 1 says that we want to graph the linear function y equals 2 over 3x plus 4. And so the first thing that I want to do is identify my slope and identify my y-intercept. So I know that since my equation is going to be y equals mx plus b, I know that my slope here is 2 over 3. And I know that my y-intercept, my b, is going to be this 4 here. Okay, so that's the first thing I want to do, is to be able to identify my slope and my y-intercept. Then I'm going to graph them. So I know that my y-intercept of 4 is going to be where the line crosses over the y-axis. So on the y-axis, I'm going to put a dot at 4, where y is 4. Next, my slope is 2 over 3. So again, that's rise over run, which means I'm going to go up 2 and to the right 3 from this point that I just plotted. So here I'm going to go up 1, 2, and then to the right 1, 2, 3, and I'm going to put a point there. And I'm going to continue doing this up 2, to the right 3, as many points as I can go, right? And that looks like the end of where I can reach going up, but I'm also going to go backwards. So instead, I'm going to do down 2 and to the left 1, 2, 3, down 2 to the left 1, 2, 3, down 2 to the left 1, 2, 3. And now I've placed all the points that I can, and all I have to do is connect all of my dots here. And I have successfully graphed the line y equals 2 over 3x plus 4. Okay, we'll talk about example 2. It's very similar. First, I want to identify my slope, and I want to identify my y-intercept. So again, I know that this is going to be my slope, including the negative sign, because it's negative 3x. And my y-intercept here is going to be negative 1. So I'm going to write negative 1. And then just like we did with example 1, we're going to start by plotting our y-intercept, which is negative 1. So on my y-axis, I'm looking for the point negative 1, which I know is going to be right below that 0. And then my slope here is negative 3. And so if I were to write negative 3 as a fraction, I would write negative 3 over 1, which tells me that from that point, I'm going to go down 3 because it's negative, and then I'm going to go to the right 1 because that's positive. So I'm going to go down 1, 2, 3, and to the right 1. I'm going to do that again, 1, 2, 3, to the right 1. And now I can go backwards. So I'm going to go up 3 and to the left 1. As many times as I can. And just like before, I'm going to connect all of my dots and end up with my awesome equation and line on the graph. Okay, for number 3, it says to create a linear function that goes through the point 1, 3. So this is a little bit different, but it uses a lot of the same skills. So at this point, you get to create any line that you want to as long as it goes through this point. So I did indicate some tips that you can use. So number 1, I said to mark the point on the graph 1, 3. So that point, you can see I already marked it. This is 1, 3. And now all I want to do is draw a line that goes through this point. And so I put in parentheses to use a consistent slope. That just means I don't want you to draw a crazy line that goes through the point. I want you to draw a straight line. So this is just a random line that I chose, right? And it goes through this point that I was hoping for. And then step 3 says to write the equation of the line that you drew. So the first thing that I want to do in order to figure out what the equation of this line is, I like to start by finding the y-intercept. So again, that's where it crosses over this y-axis, and I can see that it crosses over at this point right here. So since my equation takes the form, y equals mx plus b, and I was able to identify that my y-intercept is b, I know that my y-intercept is going to be 1. Now I want to find my slope, and so I'm going to figure out how did I get from this point to the next point. So it looks like I go up 2 over 1, up 2 over 1, and it's a consistent slope, right? Just like it said to do. And so I know that my slope here is going to be 2. So now I can fill in the rest of my equation, and I know that my equation is y equals 2x plus 1. Okay, and this is just one of the many equations that could go through this point. So your job here, right, so it says to follow along with how I created my equation and then create your own. So you can use the same steps. You can mark the point, which hopefully you already did, and then draw any line that you want that goes through it. So it might look like that. It might look like this. It could look like anything that you want it to. And then do just as I did and write the equation of your line on this blank spot here. Okay, so pause the video and try that out, and you can see visibly that it goes through the point on your graph to check your answer. Okay, everyone, hopefully we were able to do this problem here. We're going to flip over the page to the next side where we're going to review linear inequalities. So before we were just reviewing linear functions and regular equations, but now we're going to look at inequalities. This is also a review of what was taught in lesson 1. So if you feel like you need more help with this, please refer back to lesson 1 to answer any additional questions that you have. So once again, we have important things to remember here. One thing that's important is whether to use a solid or a dotted line. So you want to use a solid line when you see greater than or equal to, less than or equal to, or of course equal to. That's when we have a solid line. When we use a dotted or dashed line, that's when you see greater than or less than, because it doesn't include that value. Next thing, shading. So you want to shade above or to the right of the line when you see greater than, or if you see greater than or equal to. You want to shade below or left of the line when you see less than, or if you see less than or equal to. So looking at this linear inequality here, we have y is greater than or equal to 2x minus 4. So everything about graphing our inequality is going to be exactly like we did on the last page. The only difference is where we shade and what type of line we use. So it might be helpful first to figure out what type of line we're going to use. And since I see the or equal to, I know that I'm going to be using a solid line. So you don't have to do this, but I'm going to make a mental note here that reminds me that I'm going to use a solid line. Also, I want to look at my shading. So since I have greater than or equal to, I know that I'm going to shade above or to the right. So I'm also going to write that down just to remind myself that that's the type of line that I should be using. So now once again, I'm graphing it just the same way that I was before. I can see that my slope here is 2. So where there's a spot that says slope, I'm going to write 2. And my y-intercept is this -4. So I'm going to indicate that there as well. So just as I did before, I'm going to start with my y-intercept, which is -4. So I'm going to plot that point there. And my slope is 2. So that means my slope is 2 over 1. So I'm going to rise 2 and then go to the right 1 from that point that I just drew. So I'm going to go up 1, 2, to the right 1, up 2 to the right 1, and just as before, you want to do that as many times as you can fit on the graph. I'm going to go backwards like we did before. And now before I go ahead and just connect them, I want to double check what type of line I'm going to use. So I am going to use a solid line, so I guess I can just connect them as I normally would. But again, if I didn't have the or equal to part, then I would be using a dotted or dashed line instead. Now I want to know how I want to shade, right? So since y is greater than or equal to, we said we're going to shade above or to the right. And so since this is a diagonal line, we want to look for the values that are above, right? And so these are all above that line. So I'm going to shade this entire thing, right? It's important to make sure that we know that all of these values count. Obviously, I didn't do a beautiful job at shading, but as long as you have the idea that this whole section is part of the solution, that's the most important part. Okay, so now we'll look at example 5. It says graph the linear inequality y is less than 1 over 4x plus 6. So just as I did before, I'm going to indicate what type of line I'm going to use and where the shading is going to be. So since I have y is less than, I'm going to use a dotted or dashed line. So that's important for me to write down. Dotted / dashed line. And my shading is going to be below or to the left of the line because I have this less than symbol. So I'm going to say below / left. Okay. So just as before, I'm going to write down my slope. My slope is 1 over 4. My y-intercept is 6. And I'm going to do just as I normally have been doing. So I'm going to mark my y-intercept as 6. My slope is 1 over 4, which means I'm rising 1 and going to the right 4. So up 1, to the right, 1, 2, 3, 4. Doesn't look like I can fit any more, so I'm going to go backwards. Down, 1, 2, 3, 4. Down, 1, 2, 3, 4. Awesome. Now for my line, I know that it's going to be a dotted line, dotted or dashed. So I don't want to draw it all the way through. I just want to have little dashes. Okay, and now I want to shade below or left the line. So I want to start drawing arrows down to remind me that I'm going to shade all of this area. So I'm going to end up shading this entire spot down here. And again, I believe in your abilities to shade much better than I did. But that is my version of the shading. It is clear that anything below this line is part of the solution. Okay, so looking at number 6, says to create a linear inequality that has the point 2, 5 in the shaded region. So this is the shaded region. Anything that's shaded is part of the solution. So the tips on this are very similar to the last problem that we did like this. So we want to mark the point on the graph, 2, 5. So I did that here. I even labeled it 2, 5. I want to draw a line on the graph. So I can draw any line that I want to. Doesn't really matter. And so this is the line that I created here. And now I want to shade above or below the line so that 2, 5 is in the shaded region. So my line is here, and I decided to shade below my line so that 2, 5 would be in that spot. If I had decided to shade above instead, then 2, 5 would not be in the solution. So make sure that when you choose where you are shading, that you shade it so that it is within, that the point is within the region. Last thing I want to do is write the equation of the inequality that you drew. So you should follow along with how I did that and then create your own. So I will write the equation for my inequality. If you look closely, I used a dotted line, which makes me know that I'm not gonna have or equal to, I will just have greater than or less than. And since I shaded below, right, going back to my notes up here, that means that I used this symbol. So my inequality is going to be y is less than, and if we look at my slope, I went down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. So my slope is -1 over 2 x, and my y-intercept, it crosses over right here at 10. So my y-intercept is 10. Okay, so that's the equation of my inequality. You, again, can create any inequality that you want as long as this point is still within the shaded region. Okay, as long as it's still within the shaded region. So pause this video, make sure that you have these parts written down. Okay, and then create your own inequality where 2, 5 is part of the solution. Okay, so I hope everyone was able to do that. We are moving on to the next page and we are almost done with our lesson. Thank you guys so much for being patient and going through these examples with me. I hope that these were helpful and that you feel more comfortable with graphing linear equations and inequalities. So now we're going to talk about systems of equations. So I feel like most of you guys probably talked about that a bit in your classes before school closed. But just a quick refresher, a system of equations is just when you have 2 or more equations at one time. The solution to a system of equations is the point where the 2 equations intersect, right? That's the fancy term, but in other words, you can think of where they cross. So here, the question is, what is the solution to the following system of equations? So we see that we have 2 lines on a graph, and I can clearly see that they cross over right here. And that point is 2, 4. So my solution is just going to be 2, 4. Okay, so now pause the video and look at this example here. Try this one and write down what solution you got for this. Okay, so for this example, we can clearly see that they cross over right here. So I like to mark that point, and the coordinates of that point are 3, -2. So that is what you should have gotten for your solution. Hopefully that's what it is. And if not, please go back and check how you marked the point incorrectly. All right, so moving on. Again, most of you guys have seen this in class already. Now we're going to graph a system of inequalities, a system of equations, and then identify the solution. So just as before, I'm going to graph my equations. My first one is y equals 2x plus 1. So I'm going to start with my y-intercept, which is 1, and then my slope is 2. So I'm going to rise 2 over 1, and I'm going to keep doing that until I can't anymore. Okay, and since we are back to equations, no longer looking at inequalities, I know that this is going to be a solid line, because it has my equal sign. So I'm connecting this, and now I need to graph my second equation. So my second equation is y equals 3x minus 2. So I know that my y-intercept is -2. So I'm going to mark that on my graph. And my slope here is 3, which means 3 over 1. So I'm going to go up 3, 1, 2, 3, to the right 1. Up 3, 1, 2, 3, to the right 1. Up 3, 1, 2, 3, to the right 1. Oh, looks like they intersect there. Up 3 to the right 1. And then I could do the opposite. So I'm gonna connect my points here. Okay, And I can see that they cross over at this point right here, which if I look at the coordinates of that point, my x is 3, so I can write 3 comma, and my y is 7. So my solution here is 3 comma 7. Okay, I want you guys to try this second example. So start by graphing your equations and then find where they intersect and write down your solution. Okay, so for example 2, you should have gotten the point 4 comma 10 as the solution. This is where they cross over after you graph both of them. So make sure you got that answer. If not, please rewind the video back to question 1, and hopefully that will help you with problem 2. So we're going to move on to the next page, which is talking about systems of inequalities. So before we were talking about systems of equations, now we're talking about inequalities like we were working with before. So similarly, a system of inequalities is just when you have 2 or more inequalities at one time, just like systems of equations. A solution to a system of inequalities is the region that is shaded by both of the inequalities. So before we were shading certain areas, certain regions, and that was the solution. So now the solution to a system of inequalities is just the section that is shaded by both of the individual inequalities. So we want to practice sketching or showing the solutions to systems of inequalities. So I have this system right here, and my first job is I want to figure out where the shading is going to be. They were already graphed for me, which is nice, but the shading wasn't done, and so I need to figure out where the shading needs to happen. So first I need to identify which line belongs to which inequality. I see this less than or equal to, and I remember that that means that that's a solid line. So that tells me that this line here must belong to the first inequality because it's a solid line. So since it's y is less than or equal to, I know that the shading is going to happen below my line here. So this would be the solution to the first inequality. The second one I know is this line now, and this one is also less than, so I know that this shading is also going to be below the line. So I'm going to shade this. And so now I know that the solution to a system of inequalities is the section that is shaded by both of the inequalities, which I can see is this spot right here because both of the shading happened. So if I wanted to sketch the solution, that's going to be this section right here because that's where the shading overlaps. Okay, so looking at example 2, we're going to do something super similar. First, we want to identify which inequality belongs to which line. So once again, I see that there is an or equal to, so I know that that's going to go with the solid line. I see that this is y is greater than or equal to, so I know that I want to shade up or to the right. Right, so here I can see that this way is to the right and also above. So I'm going to shade this section as the solution for this inequality. And now I'm going to do the same thing for here. I see y is greater than -2, so I know that I want to shade above this line. And lastly, I can see that this is the section that is shaded by both my blue and purple pen. So I know that my solution to my overall system of inequalities is this section of the graph here. Okay, so please try these out or check your solutions. Make sure that you understand why these are the solutions to the two systems of inequalities, and then please try both of the U-tries. So just to quickly go over the U-try 1, one thing that's important to note is that This is y is greater than negative 3x plus 5, which means it should have a dotted line, but accidentally on the graph itself, it looks like a solid line. So don't be too confused by that because it should, in fact, be a dotted line. But if you identified the lines correctly and you did your shading correctly, this will be the section that is shaded. If you move on, this is practice time now. So practice time asks you to graph the inequalities and then also shade the regions. It also asks you to graph the system of equations and write down the solution. On the back side, these are questions that were similar to our questions 3 and 6 from the packet. So please refer back to the tips, refer to the other examples that you guys did, and hopefully you feel successful in completing these problems. All right, guys, that wraps it up for lesson 3. It was a little bit longer than I wanted it to be, but I can't go back and change it because I used pen on the papers. So hopefully you were still able to gain a lot from this lesson. If you have any questions at all, please don't hesitate to reach out to me, to reach out to your teachers, and definitely be sure to refer back to the examples from earlier in the video as well as examples from lesson 1. Okay, you guys are great, and I hope that you find success with this lesson and the practice problems and all of the lessons to come.